Hello, my name is Eliza Bosmans, and this is my Lab 5 magnetic braking Faraday's law. Purpose of this lab is to collect data of a magnet falling through a conductive tube of aluminum foil and see how it relates to Faraday's law of curly electric fields. The results: when a magnet falls in a tube, it forms a curly magnetic field like that in Faraday's law, which then slows down the magnet so it goes at a constant velocity. Then key ideas here, we have Faraday's law, which associates the electromagnetic force and the electric field side and the derivative of flux, magnetic flux. And then we have the equation for magnetic fields, and this is force from magnetic fields. And then this is magnetic flux here, which looks very similar to electric flux, equation for gravity, and this is Lenz's law. We have the experiment, system, surroundings, and procedure. System was the roll of aluminum foil. The surroundings was everything else. Oh, sorry. The system was the roll of aluminum foil and bar magnet. Surroundings was everything else. Procedure, north pole of bar magnet marked, for which is just found with a magnetometer app. Drop magnet through tube and record the time it takes for the magnet to fall, which it doesn't matter which. This was the procedure that was given, but it doesn't matter which way the magnet falls, because either way it'll become polarized in a certain direction. And then you conduct experiment 5 times and find an average time that it takes. And this is the experiment setup. This is my hand right here. This is our tube wrapped in aluminum foil, and the magnet is placed up top right here. The length of this was 0.46 meters because I counted from where the aluminum foil stopped, not the cardboard. The width of this was 0.006 meters. Magnet's mass was 0.025 kilograms, inner radius and outer radius are here. This was the coding section, which gives the model of our magnet, which I will show you code now. If we look here, this is where we set all of our constants. And then this is creating the tube of aluminum foil, which is just a bunch of rings stacked on top of each other. And then we go down here, and this shows the bar magnet. This is the red and blue piece moving through it. We have our dipole, which is what the magnet becomes when it's dropped into the magnet acts like a dipole. But that's what we need to use to calculate the electric field going through the aluminum tube. This is to calculate the flux when the magnet is dropped through the stack of rings or the aluminum tube. And this tracks, it doesn't track, it loops through for a certain number of a certain amount of time, the magnet falling down the tube. And then we see here, this is computing all of the flux, the different currents, or just the current in the aluminum foil in the ring. And then down here, this is the rest of the code. And then if we go back, oops. We go back up here, we get the rest of our coding, that's done, and this is the velocity versus time graph that's made. Then the conclusion, average time through the tube experiment was 1.476 seconds, and that was the average across 5 times, and the glow script was 1.51 seconds, which is very similar, but experimental was less. Errors, human error, don't start the stopwatch at the right time, drop the magnet at a certain inconsistent distances, so the time is different. You're not holding the tube perfectly straight, so it hits the walls, and that causes maybe a time delay. The code is idealized. Earth's magnetic fields, we're standing not at an exact point in the magnetic field, so if you conducted this in a different location, it might change. Then there's other factors that are affecting the magnet falling. Discussion, what if the resistivity of the conductor were reduced as close as possible to 0? How would the dynamics of the falling magnet change? This is what would happen. The force of the magnet falling through would increase until it gets closer to gravity. The magnet would fall very slowly. What if holes or slots were cut into the tube? And then current would not be consistent. The force slowing down the magnet would be less strong because less current would flow because there's chunks missing out of the piece where the current is. The magnet would fall faster. And that is the end of my presentation. Thank you.